Okay, so we've got this sledge here of mass 39 kilograms, so its weight will be 39g, and if you resolve it then parallel to the plane and perpendicular to the plane, you get these components: 39g cos alpha, 39g sine alpha. Now we told that alpha can be found by knowing that tan alpha is 5 over 12. So of course with a right angle triangle, remember now tan is TOA, isn't it? Opposite over adjacent. Yeah, TOA, O over A. Yeah. So my O is 5, opposite the angle there. And my adjacent is 12. So the adjacent side here, of course, next to the angles. Use Pythagoras then. So 5 squared, 12 squared is 169. Added together, and then square root that is 13. Okay, so the 5, 12, 13 triangle. So from there then you can work out your cos alpha is A over H, of course, 12 over 13. And your sine alpha is O over H, opposite over hypotenuse 5 13. So that will help us, of course, with some of these calculations here. So in part A then, we're told, given that the sledge is moving freely down a line of greater slope, calculate the magnitude of acceleration. So it's accelerating down, okay, just under its own weight, basically, this weight component here. There's nothing pushing it down, it's just falling because of this weight component. Of course, there is a resistant force then, if it's going down, there's a resistant force of friction, okay, which acts up the plane. Okay, so what I'm going to do, I'm going to resolve, in this case now, first of all, I'm going to resolve parallel, okay, to parallel to the plane, okay, and of course we're using Newton's second law. So parallel to the plane, there's motion in the plane, so we're going down, so this will be the main force, 39g sine alpha. Of course then we need to take away the resistances, which is the friction, okay, and that's it. You know, you've got that pulling it down, you've got the friction opposing it. That will equal then to the mass times acceleration. Now the mass is 39 kilograms times then the acceleration, which we want to work out, okay. So we want to work out A, but also we need to figure out what friction is perhaps first before that. So if we then resolve perpendicular to the plane, we've got, of course, there's no acceleration perpendicular to the plane because it stays on the inclined plane all the time. So you've got R will actually equal 39g cos alpha. Okay, so we can then go about working out our friction, right? Because remember, friction, because the object is moving, okay? So since the sledge is moving, friction is as big as it can be. Friction is actually equal to mu r, so that is max. In the question they said that the coefficient of friction mu is, where is it, 0.3. Okay, so we've got that there. So we can put 0.3 there. And of course then the reaction, normal reaction is this. So 39 times 9.8 times cos alpha, and of course cos alpha is 12/13. Okay, so we get then our friction to be all of that. And we get out to be 105.84 newtons. Okay. So if we then sub that back in here, we can then get our acceleration. Okay. So we can say, look, sub in 1. So we've got 39 times 9.8. So 39g times 9.8. Sine alpha, of course, is 5/13. So I can write that already with the values. Okay, that I've got from there. Take away then, it says, the friction, which I've just worked out to be 105.84, and then that will equal to mass times acceleration. So let's get my calculator to work all that out there. So we get that out to be 41.16 equals 39a. Of course then to get a, I just need to do 41.16 divide by 39. Okay. we get our answer to be 1.06 meters per second squared if we leave that to 2 decimal places. Okay, as the question asked for. Okay, so then we've got part B, and in part B it says, given that the sledge is being pulled up the slope with acceleration 0.4 by means of a rope parallel to the line of greater slope, find the tension in the rope. Now, the only way go about that is perhaps draw another sketch. Alright, so I knew I had to do this, so I just photocopied it. One, I did for the other one, so it makes life a bit easier for me. But I think it's ideal to actually sketch it again, because this time now we've got a rope, haven't we, attached to the object. Okay, and there's a tension in that rope pulling it up, and because it's going up, of course, we have acceleration going that way, and they tell me the acceleration is 0.4 up the hill. Okay, and because it's going up, now friction is going to work our way down, if that makes sense. Okay, that's the way friction is going to go. So we are asked to find the tension. So if we then apply Newton's second law, okay, so we're resolving essentially, right, along the line of greater slope, as it says, or along the line of motion. Okay, along that incline there. So we'd have T, take away then the 39g sine alpha, okay, take away then obviously the friction, and that will equal to the mass, which is 39, times then the acceleration, which they tell me in the question is 0.4. Okay, so the tension, take away the resistant force, is equal to mass times the acceleration. Now, of course, it's just a case of plugging in the numbers. There's not many marks for this as such now, because we can use what we've worked out already. The friction, of course, from before was 105.84, so we just use that value there, and then you work out these values then in our calculator, okay, and we can get our tension. So 39 times 0.4 on the right hand side, okay, and then if we take all that stuff over the other side, and we get our answer to be, I believe, 268.44 newtons.